Hello class, I'm jumping to section 17.15, and instead of doing a kind of chalkboard style lecture, I just wanted to go through this quickly and highlight a few things with you. So please read this section on your own, but let's go through this just briefly and I'll point out some things that I wanted to make sure you understood. So this section is about indicators in the context of acid-base titrations. So we've already studied quite a bit about acid-base indicators. We know that they change color depending on the pH, the H plus and OH minus concentrations surrounding them. Last semester we used this phenolphthalein compound. And if I go to a new tab here, try to type, we'll just do this outside. Phenolphthalein, remember, was clear when we put it into our acidic solution. And it didn't turn pink until we added enough base to get there. So that means once it gets into a slightly basic environment, that compound turns pink. So if we look at actual a pH curve, here's the important point I wanted to make sure everyone understood, is that remember in an acid-base titration, strong acid, strong base. So we're starting down here, strongly acidic. Let's get back to this. And as we add a little bit of base, it reacts with the acid. So that means we're getting a little bit more basic. We have less acid. Remember, the products of a strong acid, strong base titration are just going to be some sort of salt and water. So as long as we still have acid around, we're going to have an acidic solution. Then we get to the equivalence point. We get this really big jump. For strong acid, strong base titrations, when you add this exact amount of moles of base that reacts with all the moles of acid, that produces just water and a salt, no excess base, no excess acid, and we have exactly pH 7, the equivalence point. Now notice this white region is the color of phenolphthalein at this pH. So it doesn't actually turn pink until we get past the equivalence point. So what we're doing in those titrations is we're using what we call the end point of the titration. That is the point at which we see the first sign of color change. That's our end point. That's an approximation for the equivalence point. But notice the milliliters of base added, it's almost exactly the same as the equivalence point. So it's an appropriate approximation. So remember in lab when you're doing these kind of titrations, where it would take the tiniest drop to go from clear to pink. So yes, it takes the tiniest drop to go past the equivalence point to get to the end point. So that one drop's worth of extra liquid is not going to affect our molarity calculations when trying to determine the molarity of the acid. So that's the important point to know. So what that means is different indicators will have different transitions at different pHs. So to choose the correct one, you need to have an indicator that changes its color that's close to this equivalence point of your solution. So if you go down here to phenolphthalein, this is the one that is the nice. For a titration where it's a strong acid, strong base, the equivalence point is going to be right around exactly 7. So that means this is a good indicator for that. It's an appropriate indicator for that type of titration. Note here, it is not useful for all acid-base titrations. So if you have equivalence points for the titrations that are pH 7 or less, that's all you could use this for. So this is an interactive thing that you guys should go through to kind of see what type of indicators would work well for what situation. So please go through this. Please go through all these examples. And again, the goal of this section is just to be able to select an appropriate indicator for an acid-base titration. In summary, section review, indicators that are used in acid-base titrations produce visible color changes that mark the endpoint, and an appropriate indicator can be used to show the visible endpoint of the titration, which is near the equivalence point of the titration. So an appropriate indicator for a particular titration must change color over range that either overlaps with or is close to the equivalence point. There you go. Just a quick summary and pointing out things of this chapter. And I'll see you guys in the next section.